Good morning, everybody, and welcome to our performance task review. I hope that you'll find this video helpful as you prepare for your own performance test coming up. So let's just jump right into the instructions at the top. It says, on the coordinate plane below, there are two graphs. Okay, the first we'll call f of x, and that's defined as x squared, which I recognize as a quadratic because of the power of 2. And the second graph is called g of x, which is just 3 times x. And so we don't know which is which just yet, but it will eventually be our job to figure that out. So let's move on to the right over here. Let's go to number 1. Number 1 says, complete the two tables of values, right? One for f of x and one for g of x, and then use that information, here's our job, to identify the intersection points. So let's make a prediction really quickly over here. If I know one of these is f and one is g, then how many points do they intersect at? So you'll notice right away that they're intersecting at 2 points. I'll highlight the first and the second, right? That's where they're hitting each other, they're intersecting. So that's one graphical way of understanding the intersection. Now we're going to actually complete the table of values. So notice that the x-axis starts from around 0 and goes to about 14. For that reason and that reason alone, I'm going to choose x values that I find convenient. So instead of starting at -10 or -2, I'm just going to go ahead and start at 0 since I can see it. Also 1, 2, 3, and 4. Now, it's important to understand that there's no reason you have to choose these points. I could have just as easily chosen the points 0 and then 2, 4, 6, 8, or any number of points. But for the purposes of this video, I'll just choose 1, 2, 3, and 4. And let's do the same thing over here with g of x. 0, 1, 2, 3, and 4. Okay, so to fill out a table of values, we know that all we need to do is plug in our x value into our function. So if I want to find f of 0, all I'm going to do is plug in 0 to x. I'm squaring it. 0 squared is 0. If I would like to find the y value when x is 1, I need to plug in 1. 1 squared gives me 1. F of 2 will give me 2 squared, which is 4. Now this makes sense because the relationship here is x squared, so we're just squaring every x value. So if you had to make a prediction, what would f of 3 be? You're probably thinking, Miss Name, it's not a prediction. I know it's 9 because I'm just squaring 3. And f of 4 would be 4 squared, which is 16. Nicely done. So now let's go ahead and fill out our table of values for g of x, which represents 3x. So f of 0 is going to be, instead of 0 squared, now we're using this rule, 3 times x. So I'm going to do 3 times 0, which is 0. F of 1 will give me 3 times 1, which is 3. F of 2 will give me 3 times 2, which is 6. So again, this time we're tripling every x value. F of 3 will give me 9. And whoops. I said one thing, but I wrote a different thing. Okay, and then f of 4 will give me 3 times 4, which is 12. Nice. Now that I've completed my table of values, we need to identify the intersection points. So look on the left and look on the right. You'll notice that both of these graphs, x squared and 3x, both go through the point 0, 0. That's a point of intersection. They both go through the same point. They also have another point in common. This point 3, 9. They both go through the point 3, 9. Now, let's compare that with our graph. We predicted that we would have 2 points of intersection. Indeed, the first one does occur at 0, 0, and the second one does occur over here. See, that's a y value of 9 and an x value of 3. So we have points of intersection at 3, 9 and at 0, 0. I'll fill that in right here for number 2. Use the table of values to identify the points of intersection. Okay, number 3 now says label the graphs in the space provided. So now we need to identify, okay, which is my x squared and which is my 3x. Well, let me have a look here. I know that x squared will go through these points. So we'll see which graph goes through 4, 16. So here's 4. I'm tracking. And then 16 is all the way up there. So this graph, the red one, must be my x squared graph since it goes through the point 4, 16. So I'm just going to go ahead and highlight it. That must be my f of x equals x squared graph. And that means that this guy must be my g of x, or 3x graph. Now, that actually makes sense based on what we've learned this unit, because we know that quadratics, or basically functions with an x squared, have the shape of a parabola. And indeed, here we have our f of x equals x squared graph is a shape of a parabola. Okay, check it out. We already did number 3 by labeling the graphs. Okay, and that's what I just did up here. Whoops. So now we need to explain how we decided. Well, I knew this in 2 ways. I used the table of values to check which graph went through the points that were listed. But another way that I knew actually is from what I already know from class. I also know that x squared is a parabola. It has the shape of a parabola. So I was able to confirm what I already knew using the table of values. Now it says, using the graph or the table of values, complete the following statement. 3x, so keep in mind 3x, that's our blue function here, is greater, okay, there's a little typo here. 3x is greater than, you want to use the THAN when you're comparing things. Okay, then x squared, and cross that is out. Okay, 3x is greater than x squared between where and where? So notice on our graph here that when x is equal to 6, for example, when x is equal to 6, the height of my 3x graph, or the height of g, is lower than the height of my x squared graph. So I would say in this case that when x equals 6, f of x is greater than g of x because it's taller, right? The y value is greater. This question wants to know over what interval from where to where is actually 3x greater. So where is g of x greater than f of x? That's what it wants to know. Well, notice it's only in this little section right here. Look, it's only in this little section right here that the blue curve lies above the red curve, right? Or that g of x is taller. Because once we go beyond the value of x equals 3, what happens? My red curve is now the taller one. So I hope that I didn't confuse you with all my lines, but I'm trying to have you see that g of x curve is actually taller right over here in this space. Okay, because it's higher. So we would say between these 2 points, between x equals 3, that's where we would begin, between x equals 0 up until x equals 3. As soon as we move beyond 3, like as soon as we go to 4, for example, suddenly now they switched who's the taller one. So I would say 3x is greater than x squared between 0 and 3. Or you could say between x equals 0 and x equals 3 to specify these are my x values. All right. Number 5 says the graph of f and g intersect at 2 points. Write down the coordinates of these 2 points. Okay, well, we've already written those before. We'll just rewrite them, 0, 0, and 3, 9. But B is where this really gets interesting. It says, use algebra now to find these coordinates. Okay, now you're learning something new. To find out your points of intersection between 2 graphs, all you have to do is set the first function equal to the second function. And here's what it's basically saying. Once you set up this equation, you're saying, hey, math, tell me where these functions equal each other, where these graphs are the same. And so that's what points of intersection are. It's where the graphs are the exact same. They have the same x, they have the same y. So that's what we're going to do. We're going to set f of x equal to g of x. Well, f of x is x squared. And g of x is 3x. So I'm going to set them equal and solve. Notice that what we're dealing with here is now we're solving a quadratic equation. And see if you remember from this unit, the way to solve a quadratic equation is first move all terms to the same side. So we can set it equal to 0. And then we'll factor and solve for x. That's exactly what we're going to do. I can't get x by itself because I have a quadratic, so I'm going to have to move everything to the same side. I'll get x squared minus 3x equal to just 0. And now notice, I can actually solve this by using our factoring method, greatest common factor. They each have an x to offer up, so I'm going to factor out the x. When I take it outside, we're left with x minus 3 equals 0. And now to solve, I'll set each factor equal to 0. In doing so, I'll get x equals 0 and also x equals 3. So this got a little tight over here. I'm going to rewrite it. We got x, we set the 2 equal to each other. We moved everything to the same side. We got x squared minus 3x equal to 0, and then we factored. Our answers were x equals 0, and then x equals 3. Ta-da! Okay, let's move on to the next problem. Next it says, on the diagram above, go ahead and graph h of x equals 4x. So now notice that the rule is you multiply every x value by 4. So instead of making a table of values, I'm just going to go ahead and use what I know about lines. So when x is equal to 2, when x is equal to 0, if I multiply that before, my y value is equal to 0. When x is equal to 2, my y value should be 8. When x is equal to 4, my y value should be, well, 4 times 4 will give me 16. When x is equal to 6, if I'm multiplying by 4, then my y value should be 24. And if you notice, going through these points, actually let me use a different color, green, going through these points very carefully, you'll see that actually our line has a slope of 4. Let's call this h of x equals 4x. There. It says, what are the coordinates now where h and f cross? So let's have a look. H is our green, f is our red. They cross at 2 points. I'm highlighting them right now. The first point that they cross at that I see is 4, 16. The second point they cross at is down here again at 0, 0. So we'll go ahead and write those in. They cross at 0, 0 at the origin and at 4, 16. Kind of interesting. Now let's look at C. Can you predict where k of x, which is 5 times x, and f of x, which is x squared, where do those cross? Now without even drawing a graph. Well, here's what I hope you've picked up on so far. When we wanted to find where x squared crossed with 3x, well, they crossed where x equaled 0 and where x equaled 3. When we were checking where x squared crossed with 4x, or where they equaled each other, well, they cross again at x equals 0, and this time at x equals 0, and where x equaled 4. Now we're asked, where does x squared and 5x cross? So probably, using the pattern in front of me, I would say probably x equals 0 and x equals 5. And that seems to make sense because when x is 0, these two are the same, right? The equation is true. 0 equals 0. And when x is 5, if I plug it into the left, I get 5 squared, which is 25. And if I plug it into the right, I get 5 times 5, which is 25. So again, it's true. My equation is true when x is 5. So they're probably going to cross then at 0, 0 and at 5, 25. Where do you think now the graph of p of x, which is nx, and f of x, which is x squared, would meet? So the pattern again is this number in front seems to be where the second point where they're crossing. So let's make a prediction. The first point will likely be 0, 0, and the second point will likely be n in the x position, and then the y value will be n squared, just like it's been here, here, and now here. We're squaring the x value. Now we're asked to actually support our reasoning using algebra. Let's do it. So again, to figure out where these will equal each other, we need to set the two functions equal to each other. Now, to solve this, I'm going to go ahead and move everything to the same side. So I like to keep my x squared positive, so I'll move the nx to the other side. I'm left with now 0 equals x squared minus nx. I hope that you will forgive me. I'm going to put the equals 0 on the right just because I like seeing it that way. It's easier for me to understand. Okay, now we can use GCF again They both have an x in common. When I factor it out, I'll be left with x minus n. And I'm now fully factored, so I'll set the first factor equal to 0, and I'll set the second factor equal to 0. Solving for x, we get x equals 0 is the first point of intersection, and x equals n is the second x value where they intersect. And that actually matches right here and right here. I hope you found this video helpful, and I wish you the best of luck today.